Alright, this is lesson 10.5 in intermediate algebra, and it's called graphing parabolas. And what we're going to do here, first of all, let's do just some real basic review. Now, when you draw a line is in the form like 3x plus 2 equals y. Alright, notice there's a couple things to keep in mind. We have two variables, and there are no exponents on either one of the variables. There's not a squared or a cubed or anything else on the x or the y. That means when we draw a picture of that equation, we get a straight line. Alright, when we have something that has a quadratic equation, so remember, a quadratic equation has a number, an x squared, a number, an x, a number without an x, and a 0. That is a quadratic equation. And that's where you use your negative b plus or minus a square root of b squared minus 4ac all over 2a. Okay, where you use the quadratic formula to solve for x. Alright, so what we're going to do in this lesson is we're going to learn how to draw pictures of quadratic equations. So in a quadratic equation, again, is in the form of y equals a x squared, a number x squared, plus a number x plus a number. Okay? So that's what we're looking for, is a picture of a quadratic function. And a picture of a quadratic function always looks like it always is a parabola. A parabola looks like this, or it looks like this. It's the only options you have. It doesn't do this, it doesn't do that. Okay, it either opens up or it opens down like that there. So we're going to look at how to graph these guys given our quadratic equation. So we will put that there, and we will start with a quadratic equation such as, let's see if I can find one real quick. Y equals x squared minus 6x plus 5. Alright, a couple of the things that we're looking for. When we're talking about a parabola, let's just draw one here. We have what is called a vertex, which is the lowest part, or if it was this way, it would be the highest part. Okay, it would be that part right there. Okay, so we've got a vertex. We also have where it crosses the y-axis and where it crosses the x-axis. So if I can find those parts to this parabola, I can graph it. Fortunately, it's pretty easy to find the parts to the parabola there, because well, let's get this drawing out of the way here for a minute. The vertex. The vertex is, write this formula down, negative b over 2a. Okay, that will be that'll be the x part of the vertex, because remember, any point on a graph has really two. You've got over this way x and then down this many y. Well, this gives you the x, and then I'll show you how to find the y. Alright, so the x is negative b over 2a. Well, here's the a, here's the b, and here's the c. So x equals negative, what is b? Negative 6. So this negative here is this one. And then 2, what's a? Is 1. So 6 over 2, so the x is 3. So the x part of the vertex is 3. Alright, how do I find the y part of the vertex? Well, I take the 3 and I plug it in here for x there and for x there. So my y is going to equal what my x is, So that's going to give me 9 minus 18 plus 5, or y equals negative 9 plus 5 equals negative 4. So my vertex is going to be at the point 3, negative 4. So there's my vertex. And actually, one of the things that you can do, and I'd suggest doing, is draw a horizontal line through your vertex. Okay, and you'll see why I did that in just a minute. So I've got 1 point there. All right. Then another point I want to find is where this parabola goes across this axis. It always goes across this axis at this point right there. Y equals whatever C is. So y equals 5. So it crosses at 1, 2, 3, 4, 5. Crosses right there. Went up 5. Okay. Now, this is one of the reasons you drew the line. Notice, how far over here am I? 1, 2, 3. That means the other side of this has a point as well that's on the parabola. Now see what's going on? You're going to get a parabola that looks like that eventually, but we don't have enough points yet to make sure. But that's why you drew that vertical line, is so you can say, okay, well, it crossed the y-axis this many over, so there's going to be a line where it crosses this many over. So we went 3 this way, 3 this way. Okay, so the next part is, where does the parabola cross the x? Okay, it crosses the x, and let's see if I can get rid, what am I getting rid of? Lots of stuff here in order to try to, okay, and I had my cool little vertical line here. And I had it, the vertex, sorry, it's just so hard, this whole thing won't erase. 3, 1, 2, 3, 4. Okay, so I had the vertex there. Alright, so now I want to find out where it crosses the x-axis there. It crosses the x-axis at wherever you find x in the quadratic formula. Okay, so if we put in a 1 for A, a negative 6 for B, and a 5 for C, and we solve, we will be able to find out where in the world it crosses the x-axis. So let's go ahead and do that. In fact, this one here, before we do the quadratic, let's see if we can factor it first. Can we do this? Can we put an x there and a 5 there, or and a 1 there, and a negative, and a negative? Because what happens? Negative 5 times negative 1 is positive 5. Negative 5 plus negative 1 is negative 6. So that works. So I didn't even have to do the quadratic. I could solve it by just factoring, and my answer is it crosses the x-axis at both the number 5, 1, 2, 3, 4, 5, and at the number 1. Okay, so you always measure when it has 5 and 1 from the 0. So we went over 1 and 1, 2, 3, 4, 5. Now I can draw my parabola a little bit more accurately. Now notice what happened here. When I solve for x, what I'm doing on every single equation that I solve for x, the answer for x will always be where the graph crosses the x-axis. That's what that means when you solve for x in any problem, is where does the drawing of that equation cross the x-axis. Okay, so that's pretty much it. If you look on the bottom of page 633, there are the 3 rules that I just went over as far as graphing. The y-intercept will always be whatever number this is, C. And if you draw your vertical line and you go over 3 here, you go over 3 here, along the same line there. X is when you solve it using the quadratic formula, or you just break it down into two binomials and solve it. That's where it crosses. And the vertex is always going to be at negative b over 2a. That'll be the x value, and then you take that number and plug it in the original one to find the y value, and that'll be where the lowest part is, or if it's this way, where the highest part is. Okay, let's look at example number 2, and we have y equals negative x squared minus 2x plus 3. Alright, so if we look back at the bottom of page 633, it tells us the y-intercept, where this graph crosses the y-axis, will be at this number there. So let's go ahead and put that up there. There's the y-intercept. That's where it crosses the y-axis. Alright. And this is something I don't know that the book even tells you yet, but I'm going to tell you. If the number in front of your x squared is negative, the graph is going to look like this. If this is a positive, the graph is going to look like that. Okay, so we know just from looking at this equation that this parabola is going to go like this, with that being the vertex. Or I'm sorry, the y-intercept. So I guess it's not going to necessarily be right there, but it is going to, do something like this. It's going to, it's going to go down. All right, so that's what we found right there, is where it crosses the x-axis. The next part is, okay, let's go ahead and set this equal to 0. We're going to change that y to a 0. You always do that because that's we're looking to see where where the graph crosses the x-axis, because that's what x equals. And when a line crosses the x-axis, if it goes through this point, what is my y? My y is 0. It didn't go up, we aren't down. We're right there on the line, so y is 0. So I'm interested in some point along here. I want to find out what x is, and I know that my y is going to be 0. I'm not going up or down, so I'm going to make that y a 0 and see if I can figure out what x is. Alright, so let's go ahead and change the sign of everything there so that we don't have a negative in front of the x squared. And you can do that. Just change all the signs. Alright, and then let's see, can we break it down this way? If we can't, we're going to have to use a quadratic formula. But it looks like we might be able to do it. 3 times negative 1, negative 3. 3 plus negative 1 is 2, so that works. So x is equal to negative 3 and 1. So that's where it crosses the x-axis, at negative 3 and at 1. Okay. Alright, so the only other thing I don't know yet is I don't know where the vertex is. But my vertex I do know is at negative b over 2a. And again, I keep referring back to bottom of page 633. Alright, so what is my b? My b is, looking at my original problem up here, my b is negative 2, and it's over 2a. What's my a? Negative 1. So this is 2 over negative 2, or negative 1. That's my x value. So my x value is at negative 1. So it's somewhere along this line, right? Somewhere along that line. Okay. Now I know that one of my points was here and one's here. And see, they're two away from the line there. This is called an asymptote, just so you know. But 2 over there, 2 over there. This is 1 away, so I know that there's going to be another point 1 away over here. So let's put that there. And we will continue on the next video on finding exactly where the vertex is. We know that this is the x part of the vertex, but we have to plug negative 1 in for this x and for that x. So next video.